So this is session 3 out of 4, you'll be glad to hear. And there's no point in me introducing myself again. So what we hope to cover in this session is to talk a little bit about Azure storage. So we talked about some relational databases already. We will refer back to those because I did make a promise earlier to essentially talk about some other services on the platform. We'll then talk about some other platform services, and we'll look how we can move workloads within the Azure environment as well. So moving data is going to be the emphasis of today's session, this session. So earlier we mentioned this guy, the Azure SQL database. And we mentioned that with the Azure SQL database, there were a few shortcomings. So there was the cross-database queries that didn't work for us. There was no SSIS, SSRS, SSAS, or the SQL Server agent. But there are actually other services natively available on the Azure platform that allow us to bridge some of those shortcomings with the platform services. So at the top of the list, we have Elastic Queries. And Elastic Queries is really good. So if you've got, think of it like multi-tenanted applications, so you've got loads of virtually identical databases, and you wanted to query across all of those databases. So take a scenario where your data is sharded across multiple identical instances. Then what you can actually do is you can use Elastic Queries to execute queries across multiple Azure SQL databases, despite them not natively supporting cross-database queries. You've also got the Elastic Job Agents, and the Elastic Job Agents essentially do just that, but they could do those in almost a manner that a traditional SQL Server agent would behave in. So it allows you to kind of bridge the gap where you no longer have that SQL Server agent available to yourselves. And we've got Azure Functions. Has anybody heard of Azure Functions before? Awesome. So we've got one person. So Azure Functions is really good. It's a serverless technology for ourselves. Serverless is the next abstraction it's the next step after platform services, because essentially up to platform services, you still have to provision capacity. Yeah, you don't have to think about all the different elements of what that capacity looks like, but essentially you still have to provision either DTUs, you have to provision your vCodes, you have to provision your app service plans that are going to run your website. So you have to think or preemptively have a think about what your workload is going to be like, so you can preemptively scale that architecture or reactively scale that architecture. With serverless, the beauty of that of serverless is the fact you don't have to worry about it. So you essentially provision your functions into Azure, and you let Azure worry about the scaling side of things. So essentially what would happen in the background, as your functions are called more and more, that function is copied onto more nodes that can receive those requests and can facilitate those requests. So you don't have to worry about that capacity ahead of time. And you're also only paying for what you consume. So you're not paying for 50 DTUs to sit around potentially waiting for somebody to query them. You're essentially paying per execution in most cases with serverless. So that's where Azure Functions sits in. And the reason why I mention Azure Functions now is because you can use Azure Functions to execute code against your SQL databases as well. So they are small snippets of code. They are very good because they can be called from endpoints as well that you have configured for those Azure Functions. And the good thing is you can use them to facilitate some of those jobs in terms of executions against your database in place of an Azure SQL Server agent. And then we've got Data Factory. And this session is going to be heavily focused on Data Factory, in particularly Data Factory V2. And that's because Data Factory V2 supports SSIS workloads, which I'm not going to go into because I don't know anything about them. But it also supports an operation called copy data, which I'll demonstrate shortly. And that essentially allows us to copy data from a like-for-like data from a source to a destination, which we'll use to copy data from one Azure SQL database to another Azure SQL database, despite one not strictly being able to reference the other natively. There is other tools for reporting purposes, like Power BI, and the next session you'll be glad to hear, I'm sure, is going to be fully about Power BI, so there'll be a whole session dedicated to that. And there is analysis services. So for people that are currently reliant on SQL Server analysis services, SSAS that was mentioned earlier, there's actually a standalone service available in the Azure platform that allows you to push that workload into analysis services instead. So you've got all of the different areas that we'll talk about. And what we have in the first instance is data factory and copy data. So I actually want to drill into a quick demo as to what the provision of data factory looks like and what that copy data operation looks like as well. But I'm going to try and full screen this because I'm wary of the fact we're not getting much screen space to play with. So within my Azure environment, what I'm going to do is I'm going to type in data factory when I go to provision a new resource, and data factory will show up. And it's quite simple to actually provision a data factory simply because there's no configuration to it whatsoever. We'll specify a name, event data factory, which is already in use. So event data factory Dan, highly original. And I'll pick explicitly version 2, which has got all of the latest functionality that we're going to be utilizing within today's demos. So as per before, I'll pick resource group to provision this in. I will stick to the West Europe region because that's where the rest of my data is. And Data Factory v2 can now natively integrate to Git repositories, and those don't necessarily have to be hosted Git. It could be Git within Azure DevOps if you have Git style repositories as well. But I'm not going to integrate my Data Factory with an existing Git repository. So I'm just going to press create, and this will actually create the Data Factory very quickly for us. At which point we can go in and see what the copy data looks like. Because anybody around here had a look at Data Factory before? Yeah, a few people. Brilliant. Brilliant. It is a very good tool that it's not always marketed quite so well. So that's taken a while. I did, as per before, create one already, which I believe is this data factory. Oh, there we go. So that one's just been created. But it's plain hiding with me. So just navigate back into the resource group, event data. We're just going to the pre-created one. So once we open up Data Factory, if we click Author and Monitor, that's where we get to see the whole Data Factory screen, which we get to play around with. And if I just zoom out a tiny bit here, we have a couple of, I guess, get started out of the box projects that we can leverage, and one of those smack on in the middle of the screen is copy data. So essentially that's what we're going to do. I have 2 Azure SQL databases in the background. 2 out of the 4 I moved into my Elastic pool earlier today. And one of those is my migrated data that we migrated the on-premises database over to, which is got those 2 tables with the one view. And hopefully that would expand, but I believe, there we go. So I can showcase that we've got this data in here. And as per before, my addresses table has got 4 records in there. There we go. And my customers table has also got 4 records in there as well. There we go. So I also have an empty database here. But what we should see is that I've already deployed the same schema to that database. So a requirement for copy data is that the source is that you have a schema to copy it into. You can't copy the data structure as well as the data when you use the copy data mechanism that comes out of the box of Data Factory. So I've preemptively made sure that there is a There is those tables in there, but those tables are very much currently empty. If this loads, oh, there we go, they're not empty. Excellent. So what we can do is we can empty those tables out. For some reason, everything's decided to go very slow when you try and do a demo. And when SQL Server Management Studio dies on you, it's never a good sign. Let's just clear all of those and actually make sure that we're looking at the right tab. Select top. There we go. So that isn't currently empty. This doesn't usually happen, but for some reason today it's decided to crash on me. So, delete. So that's deleted everything from our addresses table, and we'll do the same with customers, or customer. And hopefully, we should now see the empty tables I was talking about earlier. Perfect. So we've got our event data that's empty, and we've got our event data migrated that's currently got the data in there. So what we'll do then is we'll just jump straight back to Data Factory, and from there we'll see how we can copy this data across. So in Data Factory, when I select copy data, I go through a very similar 6-step process that I went through with the data migration assistant. It's pretty consistent. You have to specify a source and a destination, so there's no surprise there. I'm just going to call this particular task copy data. And I want to run this once. I can actually configure a schedule if I wanted this to execute periodically as well. And it would be configured in the form of a trigger that I can then leverage afterwards from inside Data Factory as well. And straight away, we have to specify the source of our data. So in here, we have a lot of different data sources. If I click on Create a New Connection, we can see a lot of different types of data sources that are currently supported by Data Factory. And I think there's more being added pretty much all of the time. But essentially, I want to type in, or go to Database, SQL Server. There should be, we'll just go for SQL Server. Perfect. And we are going to connect from SQL source. So the server name, which we have here, is the same server that we had before, and that is, if we go to event data, it's event data dot databases dot, it should be dot databases dot should show up in here. .windows.net. There we go. And the database name that we want to copy is event data migrated. So we are going to populate that from there. I'll type in my credentials and authenticate by typing in the password. So it does have native integration with Key Vault as well, but unfortunately, due to time, we haven't had much chance to cover Key Vault in today's sessions. So if I press test connection, the test should succeed, but if it fails, I'm pretty sure it will work anyway. So we'll go with that, select our source, and click Next. Okay. And that is because inside the SQL Server and the firewalls and virtual networks, I've got this little box disabled, so essentially other Azure services cannot natively access my database server. But if I press on and press save, that should give Data Factory and other services native to the Azure environment access to see and read that data. So if we try again, that read has now worked for us. So from in here, I will select the two tables I want to copy the data from, press next, and now I have to specify destination. So similar as before, I will create a new connection and I'll call it SQL destination. But first I'll select Azure SQL database. Not quite sure why that didn't come up earlier. And we'll call it SQL destination. I'll specify the server. And to be honest, what I did differently last time was I specified it as if the source location as if it was a generic SQL server. This time around, because I've selected Azure SQL, essentially it's able to probe my environment and come up with those values that I pre-populated manually last time, so it doesn't make any difference for us anyway. So we've got the event data empty, just to make sure I'm looking at the right database. And that is the one that did not have any data inside the columns. I would query it, but seems SQL's crashed on me again. So we'll just type in our credentials and press create. So SQL destination. And now I get to choose what I want those tables to map over to. So just because I have to have an existing schema doesn't mean that that schema has got to be exactly the same. In this particular case, I've got exactly the same tables and it's mapped exactly the same fields like for like because those tables are virtually identical. So I'll press next because I'm confident that that data has mapped across quite well. And I can do all of the column mapping, but all of that has already been done for me as well. Data Factory is intelligent enough to pick up on the schema. So we'll press next. We'll say in the event of a failure we want to abort. And we should just be able to let that run. So now I can go to my monitor side of things and I can see that pipeline running, which typically should take about 20 seconds to copy that data across. That's more because the process takes a bit of time to initialize. Copying 8 rows is not going to be that intensive of an operation. And what we should see that here is we should see that succeed. So now that that's succeeded and faster than I anticipated, if we navigate back to our empty database on our empty tables, we select the top 1,000 rows, we've now got those records back in there. So that's as simple as that. Two Azure SQL databases that have no concept of one another, mapped through essentially Data Factory with a very simple workflow. So now if we dive back into the presentation, I want to show you some more cool bits. But everything's crashing. Earlier, we also mentioned that there's different forms of storage on Azure. So that was quite a heavy emphasis in terms of table data. And essentially, we mentioned Azure Tables. But Azure Tables is one of 4 storage services in storage accounts on Azure. So in Azure, we've actually got blobs. We've got tables, we've got files, and we've got queues. So starting at the top, with the blobs, we've got different types of blobs, but essentially blobs is a flat file structure that scales massively and can essentially be accessed through a REST API. We've also got files, and files behave much more like your traditional network shares, so they can be accessed through SMB. They've got a hierarchy, unlike blobs that simulate a hierarchical structure. So what blobs tend to do is they tend to incorporate a file path into the name of the documents or the blobs to actually simulate this notion of hierarchy, but one doesn't actually exist. They're very much flat. With file storage, because it behaves like a conventional file storage share, you do actually get that hierarchy. You can access it through SMB, and it supports a service called Azure File Sync as well. So if you wanted to use Azure Files, one as cost-effective storage, but if you wanted to use them to actually back up your on-site data, you can use Azure File Sync to synchronize on-premises file shares onto Azure files, and they would still track changes on-premise and would basically populate and trigger those commits into your Azure file storage. We've also got tables and queues. So we've already talked about tables being NoSQL tables, and with queues, it's a very simple message delivery service. It's a first in, first out message delivery service, which can scale to a large number of messages. So those are accessible through authenticated HTTP and HTTPS calls, and each message can be 64 kilobytes of size. Those messages would reside in a queue for up to 7 days as well. So it's quite a flexible but yet simple way of utilizing queues natively from within the Azure storage account. And the reason why we refer back to storage is because so far we've talked about data, but not all data that we're going to be storing within organizations is going to be SQL data or data stored in tables, and we still have those files at the end of the day that we have to cater for. So the good thing about Azure Storage is that it's constantly developed and constantly improved. So we've got a lot of flexibility, and in terms of size, for US data regions, last time I checked, and Europe, we had a 2 petabyte limit per storage account. In the UK data centers, it's still 500 terabytes, but in both cases, upon request, because you can do quota requests from Microsoft, that can actually be increased to 5 petabytes. Out of the box, you've got 20,000 IOPS per storage account. Upon request, that could be increased to 50,000 IOPS. And the ingress is limited to 10 gigabits per second in non-US regions, 20 in US regions, and can be up to 50 gigabits per second. So that is a lot of bandwidth and a lot of data that we're talking about moving there. On top of that, you don't actually have a limit as to how many blobs you can have, how many files you can have, and how many containers you can have. It's virtually limitless, as long as you don't exceed the size limits, of course. It's easily accessible, and there's loads of tools to access those services, and we'll talk a little bit about some of those later. And again, just as you've grown to expect, just like any other service, like managed disks, Azure SQL database, Azure Storage is encrypted at rest with 256 AES encryption as well. So one of the services I wanted to talk about, and that I'm going to bring this back to what Jamie did earlier as well in the session to tie it all in a nice bow, is Azure Blobs. So Azure Blobs are very, very cost effective. They've got the notion of tiering, which is much similar to what you would have in an S3 bucket in AWS. So you've got 3 different tiers. You've got hot, you've got cold, and you've got archive, as you can expect. Hot means that you pay low access charges for those files, but you pay more of an ongoing cost to keep those files in hot storage that's readily accessible. You've got cool, which is slightly cheaper, but you pay more to access. So if it's data that has been frequently accessed, it's probably going to work out cheaper to just remain or leave that within hot storage. And then you've got archive, which is not readily accessible. It has to go through the process of rehydrating the data, bringing it out of essentially Microsoft's archives, but it's very, very cheap for you to store that data in there. So you've got that tiering, and you've got the whole lifecycle management functionality of blobs. So you can specify what tier you want the blobs to be created against when you create new blobs, but you can then specify rules which essentially move your data from one type of storage onto the other. So you can specify, for example, if a storage account files or blobs, have not been accessed for 30 days since the last read operation, move those off to cool storage because they're unlikely to be accessed again in the near future as well. So that is functionality that's natively available. It's very good for massive amounts of unstructured data. And as mentioned previously, has no hierarchy. So you have the accounts, you have the containers, and you have the blobs. There's no folders in the middle at all. Now, any storage account has got unique URLs, which is why the name of the storage account has got to be globally unique, because the name of the storage account makes up that unique URL. So in this particular case with blob storage is the account name, .blob.core.windows.net, and then you have / the container and the actual blob name. And the same remains true for data lake. So Data Lake is a big data analytics tool. It's very good for storing very large amounts of data, but Data Lake Gen 2 actually brings the best of both worlds, because essentially it runs on top of blob storage. And actually, when you provision a Data Lake Gen 2, you'll see that you go through the same process of provisioning a conventional storage account. The same configuration is there. The good thing is that there is actual added benefits to Data Lake storage. So one of those being the hierarchical file system, if I can get my words out. So you do now have the notion of essentially folders within those blobs. You also have the Azure Blob file system driver, and the Azure Blob file system driver is part of Apache Hadoop, and essentially it means that any data that's stored within Data Lake Gen 2 can be accessed through the Hadoop file system and any Hadoop environment. So those being Azure HDI Insights, Azure Databricks, and SQL Data Warehouse. So there's permissions as well, which is the access control lists and the portable operating system interface that I've written there on the screen. And just like blobs, they have their own unique URL as well. So instead of .blob.core.windows, they're .dfs, Data Factory Storage, .core.windows.net. And the reason why I want to mention Data Lake Gen 2 is because that is where Jamie Maguire has dumped his data for us today, that's later going to be fed into Power BI as well. So there is so many tools for us to access this data that's stored in storage accounts. We've got the Azure portal, although at the present, Data Lake containers cannot be explored from inside the portal. We've got AZ copy for copying data from one location to another. You've got the REST APIs, you've got the Storage Explorer, and actually the Storage Explorer is one tool I want to showcase very quickly for those people that haven't used it already. So for those that haven't seen Storage Explorer, because I want to showcase what our source data looks like today, I'm just going to open it very quickly up on my screen. And in here, although nothing seems to be quick today, once I authenticate with my accounts, straight away I can see all of the types of storage that can be navigated through and manipulated through Storage Explorer. And Microsoft keep adding functionality to this tool, but in here I've got this event. Oh, apologies. Is that okay? Yep. Cool. Yes, and all of a sudden it looks massive. Okay, so Storage Explorer looks a little bit like this. Once you've logged into your account on the left-hand side, you can see all of the types of storage that you can use to Storage Explorer to access and manipulate in any way, shape, or form. That's Data Lake Storage 1. It's even your managed disks as well. There's other types of storage, but essentially the bit we're interested in looking at is these storage accounts. So in my Azure subscription, if we navigate back to my Azure subscription, there is a storage account called Event Data DL for Data Lake, and that Event Data DL looks like this. So essentially it looks like, as I previously said, a conventional storage account. I still have my tables, queues in there, and files. The only thing that's changed is Blobs is now missing, and Blobs is being replaced by Data Lake storage. But the containers are exactly the same. So in here, I have a number of containers. And event data is where the JSON files we've pulled out through the Instagram API earlier currently reside, of which there are 10,029. So if I open up the same storage account within the Storage Explorer, and I navigate to blob containers, we'll see in event data some of these files in a very long list over here. I've already downloaded one previously and have opened it up and have reformatted it in Notepad++ so that we can see what some of this data looks like. And don't worry, I'm not going to do any coding. You're all safe. So essentially, we've got a lot of data, but this data is highly nested inside the JSON file. So moving that into tabular format, which is what my end goal of today's session is quite difficult. There's no tool really without any coding that can actually allow us to translate that data across. But what we have is we have this. A tool I'll show you slightly in a second. Excuse me. So we've had a look at Storage Explorer. Nothing's crashed. So I want to refer to this architecture. For those of you that haven't looked at this page, Microsoft Architectures, this is their reference diagram for data warehousing and analytics and reporting. And essentially, what is happening in this picture is our data sources are being fed through Data Factory into Data Lake. Now, our data in our particular case is already in Data Lake because it's been kindly put in there by Jamie Maguire. But in here, Azure Databricks is being utilized to actually manipulate that data. But I want to very quickly showcase this page because it is very good for, although this seems to get bigger every single time I click on it. Oh, my PC's crashed. Let's try this again. This is the URL that I was trying to navigate to, and if I copy that quickly, and we navigate back to our web browser, we will see all of those architectures in here. Now, I appreciate that's quite big on the screen, but this is a very good place to start if you're looking at migrating data and traversing that data through your Azure environment. And there's a lot of architectures here which can point you in the direction of loads of the services that are natively available on the platform. And if I click on Modern Data Warehouse, we'll see the reference diagram that I've just showcased in my presentation. And when you click on any of these, what you can actually see is you can see the how the data moves from one onto the next object, and that is actually further broken down at the bottom with all of the services that have been referenced inside the diagram, so you can get a bit of an idea as to some of the services you can utilize. Now, this is all well and good, but I don't know anything about Databricks. So I'm going to leverage a service called Dataflow. Now, we've just had a look at Data Factory already to migrate straight up data from one SQL database to another SQL database. What we can do with data flows is we can move data from different data formats. So take, for example, our JSON input. I'm going to use data flows to migrate from essentially JSON data into tabular data in a CSV format so that I can feed that into Power BI a lot easier. And essentially, all of this is going to be done from a code-free data transformation. So I'm not going to type any code. I'm just going to use drag and drop, essentially, to migrate that data across. So going back to our data factory, which I have open here. In Data Factory, if we navigate back to the home page, some of the other services that are available in here, from one of those is actually data flows on the left-hand side. Looking at time, I do not have time to create one from scratch, but I'll open up one which I've already preemptively created to run you through that and how I've actually gone through the process of converting one data type into another. And essentially, for those of you who already manipulate data, what you should notice is that some of the wording is very familiar to yourselves, especially if you've done SSIS workflows. Data Factory. And we will, for some reason it keeps opening all of the wrong bits. There we go. And let's just quickly navigate in here. Technology has failed me utterly, so that's absolutely fine. So in here, if I go to the author side of the Data Factory, I can see a data flow I've already pre-configured, which essentially shows up like an empty canvas. And actually, if I click Create a Data Flow, you'll see that it just essentially comes up like this. So it's the same screen I was previously on. Now, in data flows, you have to create your data source. So this is where the data is coming in from. And you can have multiple data sources so that you can merge data as part of the process if you need to. But I've already come up with this data flow over here, which is my pre-event filtered. So, and I'll talk you through the existing data flow. So when you create your data source, you have to specify a data set that data source that's going to make up that data source. And with that particular data set, I've actually created this JSON data set over here. So I can create a new one, but instead I'm going to edit the existing data set so that you can see that existing data set that I've created. And essentially from here, I specified a name and I've specified a connection. So where is this particular data coming from? And in my particular case, mine's coming from Azure Data, well, essentially Azure Data Lake. It's coming from that particular storage account, and that's all that this particular connection is doing. So if I open it up again, you'll see that this is pointing to the URL of our Azure Data Lake container. Actually, our Azure Data Lake instance. It's not pointing to a particular container. And in there, all I've done is pasted a storage access key, which I've pre-created. Now, this particular JSON source doesn't actually specify any particular file, and it doesn't specify any particular location. So once I've populated my data set in my main overarching data flow, what I can essentially do is kind of draw into a bit more detail. So in here, I've actually specified that I'm using the event data container within my data. And the event data container, if I navigate back to my storage account explorer, is actually the container here that stores all of the JSON files. Makes sense, right? Sorry for jumping back and forth and losing my voice. And one beautiful thing I've actually preemptively done when I've pulled out this data is because I've used a lot of different files, I've decided to store the file names of those files in a column as well as part of my originating data set. And the reason why this is very useful for myself is because if we have a look, we have one set of the JSON files in this particular container called event data. But if we look at event data image, we have exactly the same set of the original images that the JSON files reference, which we want to actually reference within our data set as well. And the way the one is tied in with the other is essentially they're all named with the same randomly generated number. So I would have a .json extension file that relates to this particular image of the same file name. So what I have done in this particular data flow is I have stored that value in a new column called file name. And that's all I've done in my source data. The data factory is quite clever in the sense that it can come up with its own random schema from that. So it can essentially look at a collection of the files and it can come up with a schema as to what it thinks the data looks like for me to then use and manipulate as I please. And once you've selected your source, you can then go through any number of stages to manipulate that data by clicking the plus. And in here, I've got a number of different tasks that I can essentially leverage. So I can use the row modifier, or I can use a schema modifier. And because my schema is different in my destination to what my source is going to be like, I've essentially used what is called a derived column over here at the top. From the derived column, I've manipulated all of these fields. So I've been able to strip out particular fields. Now, the reason why I need to do that is because if I was to select my data source as my JSON files and event data, that's absolutely fine. And if I was to try and, like for like, just dump those into my CSV file, and I'll leave everything as it is, essentially, what it'll try and do is it'll try and map all of my fields as they are. But the JSON files, it'll now go through a process of validation. What it'll do is it'll scream back at me to say that, if I try and run it, it would scream back at me. For some reason, it hasn't done it. What it would essentially try and do is it would try to map a collation of fields to one field in my tabular format, because essentially it's got no notion of parent and child. It's not going to try and create multiple tables. It's going to try and shove it all into one CSV sheet, and it's not going to use multiple sheets in any way, shape, or form. Because of that, if I was to try and now run that data flow, it will have no way of knowing how am I supposed to handle this data that's currently in JSON format with a complete hierarchy into a flat structure like a CSV file. So a little bit of magic goes on in our data flow, which essentially says, and for example, if I click on any of these, in this particular case, it navigates to my categories. It navigates to my first category, and it navigates to the name field. So I navigate that structure, and I strip it out into separate fields that I wanted to map over to. And I've also manipulated some of that data as well in the process. So some of these are straight up conversions, so that they don't map straight across as strings. And some of these actually try and concatenate fields. And the one I want to draw your attention to is this one at the bottom. So if I actually click this, I get to expand and see what this particular field is doing. I get to reference different functions, everything from my schema that I've built up so far in the forms of columns, and also parameters I can store that I can reference across my data flow. But in this particular case, all I've done here is a straight up concatenation, and I have used the data image container. I have stripped out the file name as well to get the unique reference. I have added the extension, and I have also added a SAS signature at the end, which allows me to actually access that file as well as we click and navigate this particular link. And essentially that's all I've done, is mapped fields like for like from one data structure to another. And the next thing I've done there is I've actually just filtered some of those out. So I'm not interested in some of the fields where the confidence factor is very low. Excuse me. Because with that particular data structure, with the machine learning side of things, they can bring up all sorts of results, even if the confidence is really low. So what I've done is just said, just to filter out some of the data, is said just pull out the values where the confidence factor is at least 50%, where we've got some element of certainty with the data that can then be pushed out into rsync, which is our CSV file. And very tickly throat later, what we should then have is, once this process is run through, which we can monitor, I'm not going to trigger it because it will take about 10 minutes to run, is we have all of these runs in here, and we can see that our run succeeded at 10 minutes and 45 seconds. And I can click on that particular run to find out exactly what it has done, as well as it goes through the different sections. This is one that doesn't use any form of filtering. I've got one which actually has filtered as well. And this is what it looks like. So it succeeded at each stage of my flow as well. To ultimately do what I will show you now, is spit out a CSV file which looks like this, that I can now download, and I have already downloaded locally and open as a CSV. That's 4.7 meg in size, so all of those fields could be mapped across there. And I hope that makes sense. I apologize because my throat is really ticklish, so I'll speak to anybody afterwards that's got any questions. And that is essentially what we've done in our data flow. Is essentially we've used Data Factory in place of Databricks, which actually lays on top of Databricks and leverages Databricks underneath to not only pull the data in and do a straight up copy, but to actually transform the data and spit it out back into a different container in data lake storage that we can then feed into Power BI, which leads on to the next session. Thank you.